Section 8.6. This is using other integration strategies. And we're basically, these next two sections are going to be dealing with two different things. One of them is analytical ways, and we've been doing substitution by parts, by partial fractions, but there's another method that's called using a table of integrals where you look up the different formulas to do the problem analytically. And then the next section will be talking about the computer methods and the way your calculator will work problems out. So, if you're looking for a table of integrals, you can find it in two places. I have placed it in Blackboard under the Start Here tab. It's called Table of Integrals. Or you can go into the textbook in My Math Lab, go to the chapter contents, pick Chapter 8, pick Chapter 8.6, and then all the way over on the right-hand side there's a little circle with a dot in it at the top with a triangle pointing down. If you click on that, go down to the one that says Table of Integrals, and you can see them there as well. And you can also save that PDF file on your computer if you'd like. So we're using the table of integrals today, so we're going to start with example 1. And they are wanting to use the table of integrals to evaluate the integral of dx over x, the square root of 2x minus 9. And although this question could be done using a change of variable on it, they're wanting us to use the table of integrals, so we will. So if you look there, you will find one that says the integral of dx over x, the square root of ax minus, not plus, minus b is equal to 2 over the square root of b arctan of the square root of ax minus b all over b plus c, as long as b is greater than 0. In our case, the b is 9. Here's my b, here's my a. So it is greater than 0. And so let's match it up, and it turns out that this integral is 2 over the square root of 9 arctan of the square root of 2x minus 9 all over 9 plus c. I could clean that up a little bit and make it 2/3 arctan square root of 2x minus 9 over the square root of 9 is 3 plus c. And that one's done. Example 2. Evaluate the integral of the square root of x squared plus 6x dx. Okay, looking in the table of integrals, you're not going to find this one necessarily, but you will find something close to it. It's the square root of x squared plus or minus a squared dx. And ours is not quite in that form, but we could get it that way. We could take the x squared plus 6x and complete the square on it by half of 6 is 3, squared is 9, add 9 minus 9. The first 3 factor to x plus 3 squared minus 9. So my integral then turns into the square root of x plus 3 squared minus 9. In this case, the x is the x plus 3, so we're going to call it u. And the 9 is going to be your a squared. Okay, so if you look at that formula, it says, let me get it written properly. Okay, and it's in our table of integrals, it would be number 68. It says the integral of the square root, and I'm going to get rid of the plus sign because it's a minus in our case, is equal to x over 2, the square root of x squared minus a squared over 2. Oh, it's never going to fit here. Natural log of x plus the square root x squared minus a squared plus the c. Just barely got it in there. So this is going to turn into, we're going to use u's on this, so my formula is going to be a u right here, and that's going to be a u up there, and a u squared here, and a u and a u squared. All the x's are going to be u squares for what we're doing. So it's going to be u over 2, in this case, x plus 3. I'm not going to do it there. I've got to move down. X plus 3 over 2, the square root of x plus 3 squared minus 9 over 2, the natural log, x is x plus, or u is x plus 3, plus square root x plus 3 squared minus 9, close it, plus c. We can't do much of a cleanup here except for turning those square roots back into what they originally were. If you squared them out and collected your like terms, you go back to what the original question said, which was x squared plus 6x. And here you'd have an x plus 3 and then a square root of x squared plus 6x. There we go. All right, so now we're going to use a table of integrals to find the area. Find the area of the region bounded by the curve y equals 1 over 1 plus sine of x, and the x-axis between x equals 0 and x equals pi. So that means that the area is going to be the integral from 0 to pi of 1 over 1 plus sine of x dx. So if we look in the table of integrals, let me check the number for you. It is formula 44 in the table of integrals. It says the integral of dx over 1 plus the sine of ax, in our case a is 1, 1 negative 1 over a, tangent pi over 4 minus ax over 2 plus c. So for this problem, our a is 1. So this is going to turn into negative 1 over 1, so negative tangent of pi over 4 minus 1 x over 2. No plus c because we're going to go from 0 to pi. That's going to be pi over 2 minus a negative tangent of pi over 4 minus 0. So this becomes negative tangent of negative pi over 4 plus tangent of pi over 4. Negative pi over 4 is down here in the cosine quadrant, so the answer is negative. The tangent of pi over 4 is 1, so it's negative, negative 1, plus the tangent of pi over 4 is this guy here, who is also 1, so I get 2 for an answer. All right, this concludes section 8.6 because we are not going to cover the ones that have to use a CAS. A CAS is a computer algebra system. TI-84 does not have that. So we're not going to use the calculator version of that. So we're just going to leave it at this point. Examples 1, 2, and 3.